Okay, so here is our second example for working with a complex rational expression. So it says find the quotient. We're going to simplify this and find the quotient of these two rational expressions. So in the previous video we talked about how to work with a complex rational expression. And so the first thing I'm going to do is I am going to set it up by taking the numerator and the denominator and applying the multiply by the reciprocal property. And there we go. We just found the reciprocal of what's in the denominator, and now I'm going to go ahead and factor both terms. So we have x squared minus 5 right here. So this is a difference of two squares. So I'm going to get x minus 5, x plus 5. I'm going to factor the denominator, which is x plus 3, x minus 1, multiplied by the factor of the numerator, which is x minus 6, x plus 3, and then the denominator is just all by itself. So here's my, it shouldn't be there. We have our domain note. Right now we have x cannot equal negative 3, positive 1, and negative 5. Now this is just a note here because when I reduce, I have to go back to the original equation and say, hey, there are a couple numbers that we remove, but they still don't work. So I'm going to go ahead and simplify. I have an x plus 5 in both the numerator and the denominator. That cancels out. And I also have an x plus 3. So the negative 5 and the negative 3 were removed. So these are two pieces that I have to note when I'm all done with the simplification. So then I rewrite my x minus 5, x minus 6. These are the pieces that are left in the numerator. And then I have one piece left in the denominator, which is x minus 1, where x cannot equal negative 3 and negative 5. This would be my factored solution. Now in standard form, I would go ahead and just distribute these guys, and that would end up being x squared minus 11x plus 30 all over x minus 1, where x cannot equal negative 3 and negative 5. So dependent upon whether I ask for factored or standard form, those are what the answers would look like. And this is how we simplify a rational expression that's a complex fraction.